Okay. And sharing my screen now. I hope all of you are able to see my screen. Okay. So we have gone through all this until yesterday. What is the difference between a SAN and a NAS and a direct attached storage? We have seen examples of which one is used where, and the primary difference we have seen between a SAN and a NAS. NAS is not used much, so we are going to not stress upon it. SAN and NAS, we have seen that the file system is owned by storage when it is a NAS, whereas in a SAN, it is owned by the server or the host. Okay. And there are different protocols used to access the data from a NAS, different protocols that are used to access data from a SAN. And we will look at them. Yes. So this is where we were yesterday to talk about interfaces. As we have seen in multiple diagrams until now, whenever we have a storage medium, whether it is a SSD, a hard disk, a tape drive, an optical drive, whatever it is, apart from the medium itself, there needs to be a mechanism using which we can physically connect that device to a larger system. In our homes, that larger system is either your laptop, your desktop, your home computer. In a data center, that larger system can be a server, it can be a storage system. Okay. And we will also see that what are the different kinds of interfaces available and what are the various protocols. Now, see, as a data center engineer, we only have to identify the interface. Okay. We don't have to understand how that protocol works. Okay. Just a high level understanding is enough. We will not go very deep into, the nitty-gritties of the protocol. Okay. We will just identify which interface is what, because when you are in the data center, when you are replacing a failed hard drive or you're connecting a new hard disk to the system, you just have to understand, okay, this interface fits here. Okay. So you will not need to understand more than that. And once the interface is a perfect match and it fits properly, it will be fine. Okay. It will start working. So only for that purpose we are teaching you, or I'm teaching you interfaces here, but there is a lot of science behind it. We will not go into the depths of it. And each interface has its own specifications also, and the cables required, the connectors required for each kind of an interface, all of these are different. Okay. Now we will talk about these interfaces, and these are the things that are written in that additional reading material PDF that I had shared with you in WhatsApp group. Okay. And today we are going to identify them and learn a little bit about them, how they look, okay, and what is their purpose, what is the difference between each of one of them, okay, and what are the specifications. So we are going to learn that. Now, before I jump into this, I wanted to show you all something. Okay, just a minute. Let me stop sharing for a while. Yeah. So I am a person who keeps experimenting a lot. So in when I had a desktop computer in my home and no laptops, I used to do assembling, disassembling, and everything. So some parts are still available. Do you recognize this, any one of you? If you see in the camera, I'm showing you right now. Okay. Do you recognize this cable? Any one
Bus
of you?
cable,
Sorry?
bus cable.
Bus cable. That is correct, Anand. That is
Yes, sir.
correct. Yes. Anybody else? Anand is absolutely right, which means Anand has definitely opened at least one computer, okay, and seen what is there inside. So in our desktop machines, okay, uh, this is the cable, okay, using which the hard disks are connected to the motherboard. Okay, this is called as a bus cable. Okay, of course, that's I would say a layman terminology. Today we are going to understand the actual technical terminology of it. But apart from this cable, what you see at the end, okay, this black guy here, this black thing that is attached at the end of the cable, this blue thing that is attached at this end of the cable, and this thing that is there in the middle of the cable, these are called as the interfaces. Okay, these are called as the interfaces. Okay, these are the exact electrical component using which a hard disk is connected here, and the other end of the cable is connected to the larger system. In this case, this cable specifically is used in older, desktop, laptop computers, and this end, this blue end goes into a particular slot on the motherboard, and these two ends get connected to individual hard disks. So in my home computer, I had two hard drives, okay, and I could connect both of them parallelly to a single single interface on the motherboard here like this. Okay, and just imagine scale this to hundreds. Okay, so very similar mechanism is used. So I have one more kind of cable. Okay, pretty much the same thing. Okay, pretty much the same thing, but only thing is, if you see the interfaces, they look alike but they are not the same. Okay, they look alike but they are not the same. This interface, which has got lesser number of ports, okay, when compared to this larger one on the left, this one is used to connect the optical drives, okay, the CD-ROM, the DVDs, okay, this is used to connect that. Whereas this one, it is used to connect the bigger hard drives, the SATA hard drives with 7.2K RPM or okay, that kind of drives. This kind of a cable is used. So this is what forms an interface. Okay, it is the mechanism, or it is the connector plus cable. Okay, connector plus cable. Okay, both form the interface, which is used to connect a storage medium to a larger system. And these are the various types of interfaces used today in data centers. What I showed you was what was used in a home computer or a laptop, not a laptop, but a desktop. Okay. Now let us go into a little bit of deeper understanding on what these interfaces are. The first one is SATA. As we have learned a couple of classes earlier, SATA stands for serial attachment. Okay. It is commonly found in consumer desktops and laptops, as I showed you right now. In enterprises, that means in data centers, this forms the cheapest kind of low performance but high capacity storage. Okay. And what is the use case? The use case typically is for data backups and archival. Because backups and archival do not need the kind of performance that other applications like databases or web servers need. So for data backup and archiving, you need high capacity, but not so much high performance. Okay. And if you remember our class yesterday when we were talking about RPMs, SATA drives typically will come with 7.2K RPM, 7,200 revolutions per minute. Okay, that would be the speed of the SATA drives. But when you look at the capacity of the SATA drives, they will be much higher. They will be more denser. So more amount of storage can be used in a SATA drive. So they start from earlier they used to start with 1 TB. Now those 1 TB and 2 TB drives have become obsolete. Okay, they are no longer used. Now we start with 4 TB, 4 terabytes per drive. Okay, So you have 4 terabyte, we have 8 terabytes, we have 16, we have 32, and we have 64. There are higher also, but they are not yet stable. Okay, when I say not yet stable, that means there is a chance of data corruption and the disk drives going bad more frequently. Okay, because of very high density. So as you can understand, same footprint physically, same form factor. That means the size of the hard disk will not change much, and the interface which is connecting the hard disk to the bigger system, that is also not changing much, but the internal dynamics of the hard disk have improved over a period of time, and hence even at 7.2K rpm you have range of capacities starting from 4 terabyte all the way till 64 terabyte. Okay, that we have. Most commonly used are 4 terabyte, 8 terabyte, and 16 terabyte drives. Okay, these are the most commonly used. Any questions on this? Very simple. Okay. Then we understood one more term called as SCSI. SCSI stands for Small Computer System Interface, right? So it is popular for enterprise storage, and SCSI is the protocol that is used for parallel transmission and used for high performance mission critical workload. Okay. But SCSI is a old protocol. Okay. It was probably one of the first protocols that was developed in order to standardize the connectivity. But there have been advancements in SCSI, okay, and that is where the next interface comes in, which is called SAS, okay, Serial Attached SCSI. So it is an advancement of the original SCSI protocol, and this is a serial connectivity but a point-to-point variant of the SCSI protocol. Okay, SCSI could be used to connect multiple hard disks. This also does, but in a serial way. Okay, see, that's why it's called serial attached SCSI, also used in high-end computing. And whenever you see SAS drives, you will see RPM with 10K RPM and 15K RPM drives. Okay, 15K RPM drives will be a little larger, okay, because they are older, but the 10K rpm drives are little smaller. Okay, and from a performance perspective little less than 15K rpm but still acceptable. Okay, and this is what you will see mostly in storage systems across the globe today, which have been deployed and which are running. So you will see lot of SAS 10K rpm and 15K rpm drives in the storage system, which will be serving IOs to high performance, or I would say medium to high performance kind of a workload. Okay. Uh, and the speeds will be 10K RPM to 15K RPM. Okay. These will be the speeds. 15K RPM drives are a little bigger. They will be like a 3.5-inch diameter, whereas the SAS 10K RPM will be smaller. They will be like 2.5-inch diameter. Okay. And this is the one that is most commonly used. Then we go to the next protocol, which is for absolutely high performance fiber channel protocol, okay, FC. And this is what is used in SAN connectivity. We saw it yesterday, right? So whenever you connect a large storage system to a server or a host, okay, this protocol is used for data transfer between the storage system and the server. Extremely high performance, okay. Each FC connectivity, each fiber channel connectivity can support transfer rates up to 64 Gbps. Okay, it's pretty high. Why do I say it is pretty high? Okay, let me show you this. If you see any cable like this, it's like a networking cable, right? Which will have connectors like this. And we'll talk about cables and connectors in detail later. Okay, so this kind of a cable, what you see on the camera, okay, is a normal Ethernet cable, right? So This normal Ethernet cable are categorized into Cat 5, Cat 6, this kind of stuff. What is the protocol that is run on this Ethernet cable? TCP/IP, Transmission Control Protocol slash Internet Protocol. Now, what is the efficiency of that protocol? As we have learned in few classes back, it's only like 65%, right? And hence, even if you have this kind of a cable whose speed is, let us say, 1 gigabit Ethernet, like 1 Gbps, effectively you will get only like 600 to 700 Mbps. Okay. But that is nowhere close to what is the requirement of high performance databases. Okay. They require much higher speeds because the latency between the software sending out a write request or a read request to the storage serving it should be in milliseconds. Okay. And that is the reason why this fiber channel protocol was invented. Now, this fiber channel protocol is getting connected over fiber optic media. It is not copper cables, it is cables on which laser light passes from one end to another. Okay, so let me see if I can find such kind of a cable to show you. But anyways, you will find many pictures on the internet, and I will show you some of them. So in fact, let me do it right away. Okay, so this is the construct of a fiber optic cable. So the core is where laser light passes through. So this is nothing but glass. Okay, and all the other layers are just cladding or coating so as to protect this glass inside. How does a finished cable look like? A finished cable will look like something like this. Okay, so this yellow portion, what you see, that is the actual fiber optic cable. And typically, this is what you will see behind your Wi-Fi router. Okay, you will see this kind of a cable running from your Wi-Fi router to your internet service provider. Okay, and this end of the cable, okay, this is called the connector. And you see, this connector is different from a copper connector. This is not the same. This is called a LC, lucent connector. And this connector, along with this cable, supports speeds up to 64 Gbps, okay, which is way, way higher than what you can transmit over a copper cable. All right. The port into which it will get connected on the server or storage system, that is also different. Okay. That port will look something like this. It will not look like a normal LAN port or Ethernet port. Let me see. It will look, a little different. Yeah. And we have seen that this kind of a port is there in the back end and sometimes in the front end also of storage systems. Okay. This kind of a port. What's happening? Hmm. Yeah, this is a perfect example. So this kind of a cable will get connected to this kind of a port. Okay. It's called as a lucent connector. Okay. LC. So that's why sometimes fiber optic cables are also called LC to LC cables. One strange thing you will see about fiber optic cables. A single cable is formed by a pair of fiber optic cables. Okay. and there is a reason behind it. The reason behind why always it will be a pair is you cannot have light traveling in multiple directions in the same cable. Okay, laser light traveling in multiple directions in the same cable. Then lot of interference will happen and lot of data corruption will happen. And hence, one line here, one cable here, or I will say one portion of the full cable here is for TX, that means transmission, and one cable is for RX, which is receiving. Okay, so both these together form one fiber optic cable. Whereas in a copper cable, you will not have this problem because electricity we know can flow in any direction without any interference, right? So you will not have that kind of a problem in copper cable. In copper cable, you can have information flowing in both directions simultaneously. And this is again a perfect example on a switch where you have, you know, two kinds of connectivity. What you see on the left, the blank ports, that is where you see the camera, this kind of a port goes, okay, and this is how the Ethernet cable gets connected, okay, this kind of a cable. Whereas the fiber optic cable goes into a different kind of a port, okay, and always you will see fiber optic cables in pairs like this. One is for transmission TX and the other is for receiving, which is RX, okay. So this is how it will look like. Now, why did I talk so much about fiber optic cables? Because this particular protocol, fiber channel protocol, okay, this fiber channel protocol works only on these fiber optic cables, okay. It will not work on the normal Ethernet cable, okay. But the opposite is this cable, this FIBER, fiber optic cable, which is the physical media, can be used to run fiber channel protocol when it is used in SAN connectivity. It can also be used to run TCP/IP protocol when used in a typical LAN environment. Okay, when you're using it to connect one switch to another switch or one server to another server, and you want to get higher speeds with low latency, low error, okay, and all of that, then this costlier, cables can be used, okay, to connect for TCP/IP protocol also. But the vice versa is not true in this case. Fiber channel protocol can run only on fiber optic media, but fiber optic media can be used to run different kinds of protocols. It can be used to run TCP/IP also. It can be used to run fiber channel protocol, FCP also. But the opposite is not true. Okay. So please make a note of this. Fiber channel protocol can be run only on fiber optic media, whereas fiber optic media can be used to run fiber channel protocol as well as TCP/IP. Okay. And depending upon your environment, depending upon the use case, depending upon the requirement of the customer, we will suggest to the customer, okay, dear customer, if this is your requirement, instead of using copper cables, let us use TCP/IP cables. Let us use fiber optic cables for TCP/IP. The cost will increase, but you will get better performance. On the other hand, if the entire requirement itself is like high performance database needs to be connected to the storage system, then no brainer. We have to go with fiber channel protocol on fiber optic media. Okay. There are different kinds of switches for fiber channel protocol, which are separate from TCP/IP protocol switches. So those are called specifically SAN switches, and we will learn about them in our networking module. Okay. The last kind of interface, which is used specifically or more for NVMe, more for SSDs, I'm sorry, is the NVMe kind of interface, non-volatile memory express. Okay. We understood the evolution of storage medium, right? So we understood that earlier there was magnetic tapes, then we had optical disk drives, then we have hard disk drives, and then we have SSDs, right? And we understood that SSDs are the storage medium which has got absolutely no moving parts, only electrical and electronic components. They're the fastest kind of storage available, but at the same time, they are the most expensive. Okay. Now, just having a fast disk is not enough. The interface between the disk and the storage system also needs to be fast enough to transfer the data from the SSD into the storage memory and then to the server, also equally fast. And even though fiber channel protocol was 64 Gbps, that also was not enough to realize the true potential and performance of of SSD drives. Okay, that is the reason why a few years back this new interface type came in. Okay, and this interface type is called as non-volatile memory express. Okay, NVMe, and it is specifically designed for SSDs, and it drastically reduces overhead. So efficiency is very close to 100%, and the performance is much higher than even fiber channel protocol also. Okay, so what I would want you to do as an exercise for today is these five interfaces that you see. Okay, please go to Wikipedia and learn about them in terms of performance and speeds. So just type the name and put wiki next to it, and you will see this non-volatile memory express. Okay. See when it was introduced, 2011, about 14 years back. Okay. See when is the latest version that has come in. That means R&D is still going on this to improve it further. Just last year, August 5th, 2024. Okay. And if you look at the specifications, which we will see in a little while, it is extremely fast. Where did that go? Yeah. So see, SATA allows you to go up to 6 Gbps. Okay. And NVMe can actually go much higher. Where is that number? It can actually go into multiple Gbps. Anyways, so you will definitely find it. NVMe, or let us try this in Google or in search engine. NVMe speeds. Okay. So you will be able to find it here. Here, see. This is 3 Gbps. And see, you can go up to 7 Gbps. Okay. 7.5 megabytes per second. And you can keep going higher and higher. Okay. With this interface. Okay. So one exercise for today, I would request you to do is find out what are the highest speeds that can be achieved through these interfaces. Okay. And you'll find it generally in the internet, this kind of information. Okay. Like SAS can go up to 12 Gbps. Okay. Per connection. So how much can NVMe go up to? How much can fiber channel go up to? Okay. So try to understand the speeds. Okay. This is very important because when we are inside a data center, depending upon what has been designed, you will have to provide that kind of a connectivity, and the customer after connectivity will expect that kind of a performance. So you will need to understand how to configure it once we are in the storage system. Okay. So that's why you need to learn these interfaces a little. So any questions on these interfaces and what they do, what is their purpose, okay, and what are the various types? Any questions? No questions? Okay, fine. So let's move ahead. Now, before we move into the new topic, which is about storage in the cloud, uh, I will just recap everything that we did from the first class, right? So we understood that inside a data center, primarily there are three components. We have compute, we have network, and we have storage. We understood what is the role of each of these components. Servers will host the workloads like your web portal, your databases, whatever is that software. Storage system is a single purpose computing device whose only purpose is to serve data. And in between, there is a network which connects the servers to the storage. We understood that storage can be primarily of three types: DAS, direct attached storage, SAN, storage area network, and we have NAS, network attached storage. And we understood what is the difference between these three types. DAS means directly connecting. SAN means over a specific network called a storage area network. Generally, we use fiber channel protocol and fiber optic media to do this. Very high performance, but at the same time, very expensive. And used for structured data, mostly used for structured data. Then we have for unstructured data and large amounts of data, connectivity over a network, over a LAN typically is NFS. Okay, NAS, network attached storage. And we saw what is the difference between all these three kinds of storage system. Who owns the file system? We understood what a file system is. We understood what happens inside the media, how it gets logically segregated, and how that logical segregation is used by the file system and the operating system to go and read and write to specific areas of the hard disk or the SSD. Okay, so this is what we have learned till today in a nutshell. Okay, and we went deep into each one of these topics. Now, I would like to pose this question to you all. You would have heard this, right? Cloud. Okay, this term called cloud. So, can any one of you give me an interpretation, or what do you mean by cloud? What, when the word cloud comes to your mind, what exactly are you thinking? Can anybody volunteer and speak? There is no right or wrong answer, okay? Whatever comes to your mind, please speak. No problem. Anyone? Anand, Prakash, Renu, Shivani, Jagdish, Hari, Gopi?
Um, it is a pay-as-you-go model to use the services.
Oh, great. Who was this?
Hari,
Hari? Excellent, excellent. Any other interpretation?
We will create servers and will be hosted in internet. Through that, we will be managing data set.
Very good. Yes, this is also a very good interpretation. What else? I think both of you are right. Okay. So basically, what happened is many customers wanted to have their own data centers, but when they actually started to explore building a data center, it became so expensive that the economics wouldn't work out. Okay. Let us say, let us say all eight of us. Okay, we want a dedicated software for all of us, and we wanted to host it somewhere and we make it available on internet. Okay, maybe these class recordings. Now, If I have to set up a data center for it, okay, what and all is involved? First, I need power, then I need cooling, then I need internet connectivity, then I need to buy the servers, then I need to buy the network switches, then I need to buy the storage systems, okay, and then I need people who will actually help me configure it, and then I need people who will maintain it, right? Because every component is susceptible to failure. Now, just to do this, right? Do I have to spend so much? Because trust me, the cost of servers starts itself from like 1.5 to 2 lakh rupees, okay, in Indian currency, plus taxes. And then the cost of powering it on is higher. You cannot do it with your domestic power. You have to get commercial power. The rate of unit for commercial power is much higher. Then you have to put cooling systems. Then you have to power the cooling system also. So all this put together, it's pretty expensive, okay, to set up even a single rack of a data center. It will go into, you know, probably at least 18 20 lakh rupees, okay, if you have to set up a, you know, bare minimum, data center. Now, in the big in business, as you know, not everybody wants to invest so much money upfront, right? They want an option where all these things can be available at a very low cost and instantaneously. Okay. So what Anand and Hari said, both of you are right. Okay. One of you has spoken about the technical aspect of it, and one of you have spoken about the cost aspect of it. Okay, what is the technical aspect of it? The same servers, the same operating system, the same file systems, same storage, same compute available on cloud over the internet. Okay, that forms a cloud. So, as an end user of cloud, I am not sure where exactly my data is residing. They are telling me, but I physically not gone and seen it by myself or touched it by myself. I am assuming that the cloud service provider is taking care of all these things, of compute, power, cooling, networking, internet, security, backup, everything the service provider is taking care of. I am just a user who is using those services. Okay. And what Hari said is also right. Okay. Since I'm just a user who is using services, I will not pay everything upfront. Okay. I will pay as I use. Okay. Just like how you pay to your telephone provider, right? You pay either in prepaid or in postpaid only basis on how much you use, right? Our email provider, same thing, right? Electricity, or any utility for that matter, you will only pay for how much you use, right? So both of you are right. So cloud is nothing but the same data center technology, okay? When it is put in a data center operated by a cloud service provider, and the cloud service provider is slicing and dicing these all these resources and providing portions of them to each end user and charging them also like that. Okay, how much ever the end user is using, so much only they are charging. They are not charging the cost of the whole server or whole storage or the entire internet from a single user. They have sliced everything and they are charging as per usage to individual users. So that's cloud computing for you. Okay, so we will just touch upon this topic today and see who are the major players and all, but we will go deep into it in the next module. Okay. So we will start with an example. Again, here we are seeing this experienced lady. She is hosting a media company who create content, and that is used by 32,000 creators, okay, daily, and reaches 65 million readers. That means the end users who are consuming the content are very, very high, and even the number of people who are actually uploading data into that particular platform, that is also very high. So Common examples that we all know are YouTube, Netflix, and all these OTT platforms. They fall under this category, right? So with the amount of, so this is the technical problem now. With the amount of media we host, they need a cloud platform that can scale up infinitely, add agility, and help innovate to stay competitive. Okay. Now, you see, the problem statement that we had earlier was a little different than what this lady is saying here. Okay, so this lady is saying, I want the same things like what are there in a data center, but in addition to that, they need to scale up infinitely. What does that mean? Whenever they need extra, okay, they should be able to get it without any hindrance. Okay, so they should need not wait to buy a server and for that server to be delivered to them in their data center. Whenever they need additional bandwidth, they can just place a request and that additional bandwidth should be available for them. Whenever they want to move a workload from one physical server to another physical server, it should like happen on the fly. Whenever they want to explore something new, okay, it should be available. They should not be restricted by technology inside the data center. Okay, whether that server, that operating system supports this new kind of a thing or not. Okay, all those restrictions should go away. And this is typically the characteristic of a cloud service provider, because what a cloud service provider does is, since he's the cloud service providers are not building their data centers just for one user or one company, right? They are building their data center for hundreds, thousands of users and companies. So they are they have built the underlying data center in such a way that whenever any end user needs extra, okay, they will have spare available, spare servers, spare storage, spare networking, everything available. They will just add it, okay, on the fly, and end users can start using it. Okay, so that's how. So the best example I can give you is, let's say you want to open a new Gmail account. Do you really place a request to anyone that, hey boss, you give me 5 GB of storage, you give me a server, you give me internet? No. You just go to google.com, you just enter all your details, and you have your, mailbox created, right? But that mailbox is going to receive mails, is allowing you to send mails, is allowing you to store data and attachment. So all these need some hardware in the back end, right? Google is not asking you for any of those details. Google has created a mechanism, a self-service mechanism, where automatically any user, when they come to their cloud, like google.com, can go and do all the stuff on their own, and everything in the backend they will take care. Okay. They will provide space, they will provide compute, they will provide hard disk, they will provide everything. Okay. This is what is cloud for you. Okay. When the end user is unaware of physically where the data is stored, and the end user is only paying for a portion of the complete data center hardware, that is cloud computing. Now we are going to just have a small comparison between on-prem and cloud here. So what they are showing in this diagram is, if you are going to build an on-prem data center, all these components are required. We have not learned about one thing which is called as virtualization. We will learn about it in later modules. Okay. But apart from that, we have briefly learnt about what these things are, right? So in on premises, you will have all these components. All these components have to be bought by the company, and they have to pay this money upfront to place these components inside their data centers. Now, in cloud, what happens? All these things, it's the same thing, but instead of in the data center of the company, it is there in the data center of a service provider. Okay. And all the companies like you, me, big, large, small companies, they are connecting over the internet to these cloud service providers and just consuming the same resources. Okay. And the different mechanisms have been built to make sure that all this happen effortlessly and seamlessly. Okay. There is no manual intervention required most of the time to actually help the end user consume these services. Okay. Any questions until now onto what exactly is cloud? Very, very simple. So cloud is nothing but a different way of consuming the same data center resources. That's all. So don't get overwhelmed when you see new terms coming out from these cloud service providers. Okay, especially AWS and Azure are known to do that. Okay, they will not call a network a network. They will call VPC. They will not call a server. They will say EC2, Elastic Cloud Compute. Ultimately, it's the same thing. Okay. But just they are giving it different names. Okay. So don't get too confused or overwhelmed by these new words that the cloud provider will be throwing in the technical market. Okay. Ultimately, it's the same thing in the back end. Okay. It's just a new term that they are putting in, right? So don't worry about it. Now we understand, something called as a shared responsibility model. Okay. Like, what is a shared responsibility model? It is like the analogy they are giving here is what happens when make a pizza at your home versus you order a pizza, let's say from Domino's or Pizza Hut. Okay. And the same analogy can be used in on-premise data center versus cloud. When you're making a pizza at home, each and every component you have to take care of, right? So where are you going to sit and eat the pizza? What are the various components required to make the dough? Then how to prepare, like electric, gas or oven, then the fire itself and the fuel. Okay, then all the ingredients that go into the toppings. Okay, everything you have to take care, right? Whereas when you go into cloud, the cloud service provider starts taking care of few of the things for you. Okay, there are cloud service providers that take care everything for you, but not all of them. Okay, and that is where we introduce three different categories of cloud service provider depending upon how much they are ready to help you. Okay, very simple. Till what level are they going to help you? Okay, so if you go with these cloud providers who are called as infrastructure as a service providers, okay, they will provide you the all the things related to the physical aspects of a data center. Okay, like if you compare it with the pizza making, all the infrastructure related like the dining table. Okay, they will give you the soda means the Pepsi or whatever, the electric gas oven to cook, then the fire. But the actual ingredients of making a dough or making a pizza you have to bring on your own. Like you have to bring the maida, you have to dough it, you have to have the sauce, you have to have all the toppings and cheese on top of it. That's your responsibility as a customer. Okay, when you put in the data center analogy, so the infrastructure as a service cloud providers will give you the server, they will give you the storage, they'll give you the network. Okay, they will give you the internet connectivity. Okay, but they will not give you the application or the workload that you have to bring. Okay, and put it on the infrastructure provided by the cloud service provider. Okay, then if you go a little further, there are different other kinds of service providers who are called as platform as a service provider, PaaS. Okay, platform as a service. Now, what's this platform as a service? It is like they are giving a ready-made service, but only for very specific, things. Okay, and rest of the things you have to do. Like in this case, this platform as a service example is saying that they will provide only the dining table and the soda, and the rest all you have to do. Okay, this is what platform as a service do. Now let me give you an example, the Gmail example that I took, right? So Google is giving you only the email application. They are not giving you anything else, right? They are not giving you compute. They are not giving you anything else, right? They are only giving you that entire application as a service. So that's called an email platform as a service. Similarly, you have let's say ChatGPT, right? So ChatGPT is AI as a service, right? So you are not installing anything, right? You're only going to the web portal and you're logging in securely and you are starting to consume that service, right? Another example that I can take is your Dropbox or your Google Drive. It's single purpose, right? Storage as a service, right? Whatever media you have, unstructured media or whatever files you have, it will allow you to store on the cloud without buying a server, without buying a storage, without buying separately internet. Okay, it will allow you to store either to your phone, either to your laptop, either to your server, doesn't matter. So all these are examples of just very specific services being offered on the cloud without you having to worry about the infrastructure behind it. Okay, now, having said that, there are also other cloud service providers who provide everything end to end as a service on the cloud. Okay. Now, what are these examples? Like there are people, you might have heard of applications like CRM, like Zoho. Zoho is a big name, right, in CRM space. Then you would have heard of companies like Salesforce. Okay, that's also a CRM. What is CRM? Customer Relationship Management. So it's a software by itself, right? But when you go to Salesforce or Zoho, they allow you to use their complete software, which is obviously on the cloud. Okay, which means you can log in from anywhere and still you'll be able to get the same data. But at the same time, whatever goes underneath it to deliver that software, like compute, network, cybersecurity, storage, backup, data protection, encryption, everything end to end, they are taking care of. Okay. So, as a consumer or as an end user of those cloud service providers, like of if you're an end user of Salesforce, if you're an end user of Zoho, you do not have to make any other investment from your side to use their service. You pay them a fee, a pre-designated fee, and in that fee, all this is included. Okay, you do not have to pay anything else, right? And these kind of cloud service providers are called as SaaS, software as a service. Okay, the same CRM software, if you have to put on prem, okay, you have to invest in a lot. The best example I can give you is SAP. I'm sure a lot of you have heard of SAP, right? And people talk about, being an SAP expert, getting high paid jobs and all. SAP is a very good example of having that entire software stack on prem because SAP has different layers. It has a front end layer, it has a middle layer, and it has a back layer. Each of these layers need at least two servers to run on, and they have their own specifications, like they need SSDs, they need high performance connectivity to storage, they can run on Windows or Linux operating systems, you have to connect it to the internet with security, you have to take a backup because data get corrupted. And if you are installing SAP inside a data center, a customer has to give all these things to SAP guys so that they can come and implement all of this, right? But the same thing when you're taking from cloud, everything is provided to you ready made. Okay, you just have to log in to the cloud portal, tell them what you want, how much they want, and how long you want, and it's available for you instantaneously. Okay. All right. So now I ask you all a question. Which one do you think is better, doing everything on-prem, okay, or doing it in the cloud and consuming it as a service? Which one do you think is better?
Cloud service.
Sorry, in-house, on-prem,
Cloud service.
cloud is better. Okay, okay. Who was that? Hari? Is it you?
Anand, sir.
Anand, okay. You're saying Anand is saying cloud is better. Sorry, when you're speaking, I'm unable to identify because my screen sharing is on. So please do speak out your name. Anybody else? What would you say? On-prem is better or cloud is better?
If you concern more about security than on-prem is correct.
Okay, that's a good perspective. Very good. This is who?
Hari,
Hari. Very good, Hari. Very good. That's a very good perspective. What else? Think about it from a cost perspective also.
SaaS is a better option if you're concerned about cost because
Mm-hmm.
uh, you don't need to maintain the infrastructure.
Mm-hmm. Very good. Very good. Okay. Okay. Very nice. Good. I think you guys are able to understand now that cloud is just a consumption model. Ultimately, it's the same technology. Okay. And all your answers are right. Okay. Whatever you said, Anand, whatever you said, Hari, you are right. If you are going from a consumption model, cloud is better because everything is available instantaneously. Uh, if you are looking at from a cost perspective, also initial cost is less. You can quickly jump into the cloud just by giving your credit card. Okay, that's the easiest and fastest way to consume cloud. Okay, and you don't need to pay anything upfront. Everything is available, uh, you know, instantaneously, and you pay as you use. Okay, that's also fine. And from a security perspective, also, though Hari, whatever you said, if you want higher security, you want on-prem. So those things are also being taken care in the cloud, right? Cloud also is becoming highly secure. Okay, yes, there are some loopholes, but those loopholes you may experience in on-prem also. But general perception is yes, because you don't own the hardware, security becomes a shared responsibility between the cloud service provider and you. And many a times, cloud service providers just raise their hands when there is an attack. Okay, they say it's your data, but only in our infrastructure. If the data is corrupted or the data is having any kind of malicious content, we can't be held responsible. So those things are also there. But having all these advantages for cloud, why do you think still data centers exist? And why do customers still buy lots and lots of equipment and put them in their own data centers? Okay, and let me tell you honestly, the amount of data center resources currently on cloud is just 10% of the complete workloads across the globe, which means 90% of the workloads are still in on-premise data centers only. And that's only going to increase. It's not going to decrease. Okay. And I'll tell you why. First, let us see some examples and then I'll tell you why that is the case. That only 10% of, uh, you know, data center. storage or compute is available on cloud, and the rest 90% is still with customers' own data centers on premise. Okay, and there are multiple reasons behind it. So these are the top names when it comes to cloud service providers. Now, what happens here is the reason why on-prem is still used. One is for security purposes, as Hari was mentioning. The second is from something called as the cost perspective. Okay. Now, which perspective of cost? Any expenditure in a company can be divided into two kinds. One is called as capital expenditure. That means you pay upfront. And second one is called as operational expenditure, OPEX, which you pay as you use. Okay. Now, whenever any company is making capital expenditure, yes, they are paying a lot of money upfront. Okay. But those assets, those hardware and software are under their name. Okay. So they can claim something called as depreciation on asset. Okay. Because all these assets do not appreciate in value, they depreciate. Any hardware that you buy, okay, its value only depreciates over a period of time. Its value does not appreciate. Okay. Like buying an apartment versus renting an apartment, right? When you're buying an apartment, it's on your name, but when you're renting an apartment, you're only a tenant. Okay. You're not the owner of the apartment. So when you're renting, you're only paying as you use. But when you have bought it, it is yours, right? And you get tax benefits because of that. Okay. But apartment and real estate, actually the value appreciates for different reason. But if you compare it to like buying a car, right? That value, or buying any kind of vehicle, that value depreciates over a period of time. So it's buying a car versus hiring an Uber or an Ola. Okay. So that same analogy you can give to on-prem data center versus a cloud data center. So what happens is when we buy a car, the whatever is the cost of the car, we can claim depreciation and get tax benefits. Okay. But you can't do that with Uber and Ola, right? You have to, that's an expenditure. That's it. You cannot get any tax benefit out of it. Okay. So when you have depreciating assets with you, the value of that asset becomes zero over a period of time, like within 5 years or 7 years. Okay. And if smartly, by doing smart architecture and making smart investment, you can get hardware which can go beyond this 3 years, 5 years, 7 years. Then effectively, at the end of fifth year, seventh year, you're running all that infrastructure for free. Okay. You are not paying anything for it because you have already claimed depreciation on them. You have not paid tax on it, and you're showing it in your financial records as it's a loss. Okay. It's a depreciating asset. Whereas when you are doing pay as you use, you cannot do that financially. Okay. So not only for technical reasons, but also for financial reasons, customers still prefer to go and buy equipment upfront rather than renting it from the cloud. Okay. So that is the reason why each customer, especially the large ones, still have lot of on-prem data centers. Okay. In cloud, these are the three kinds of storage services that they offer. Okay, we are getting into a little bit of technology. We'll go deep dive later. But ultimately, what is this? Block means it's a SAN storage. File means it's a NAS storage. And object is a different kind of storage built for cloud. We'll talk about this later. Okay. So these are the three kinds of storage available on cloud. Nothing but the same data centers technology extended to the public cloud. So what is block? It is nothing but SAN storage. Okay. And these are the names given to it. See, Amazon has given its own name called EBS, Elastic Block Store. Nothing but SAN. Okay. Azure has given Azure Disk Storage. Google has given its own name, Google Cloud Persistent Disk. Okay, so don't get confused by these terms. Okay, it's nothing but a SAN in the backend, which means what is the characteristic of a SAN? SAN does not hold the file system. It is not the owner of the file system. Who owns the file system? The file system is owned by the server or the host. So exactly the same thing. Okay. Just because Amazon is giving a new name, Azure is giving a new name, Google is giving a new name to it, it is not changing the technology. Technology underlying is still the same. Okay. It's just a new name given by them. See, it's there in the note, right? It is for low latency, high performance. What is the characteristic of a SAN that we saw? Same thing, right? Then file. It is nothing but your NAS storage. Amazon has given a different name. Amazon Elastic File System, EFS. Azure has given its different name, Azure File System. Google has given its different name, Google Cloud File Store. But ultimately, it is the same thing. It is nothing but a NAS in the backend. Okay. Only thing, the way the end user like us is consuming it is different, and these guys have given a different name to it. But conceptually, it is the same thing. See what it is. It stores data as a single in forms of folders, hierarchy. There is a path. All this is what? File storage, what we have learned already. It's a NAS. Okay. So it's the same thing. In on-prem data center, you'll call it as NAS. When you are using from Amazon, you'll call it EFS. When you're using it in Azure, you'll call it Azure File System. When you're using it from Google, you'll call it Google File Store. Simple. Okay. No need to break your head around this. It is the same old thing. Okay. Just a different name given to it. And then you have object. This requires a little bit further understanding. So we'll discuss a little bit about object storage today, but we will go into the depths of it later. Okay. And when we are doing practicals, of course, we will see what exactly is object storage. Okay. Now, here there is a mistake. It in the name below, you see Azure Block Storage. It is not block, it is blob, B-L-O-B. Okay, blob storage. Now, what exactly is this? So let me stop sharing for a while and explain to you over video. Okay. Is there a question on chat? Prakash, you have a doubt. I have a doubt. If we buy any SSD or HDD of some size, let's say 1 TB, we get around 900 GB. Why so? Even in data centers, heavy storage systems, does it happen? Yes, absolutely, Prakash. Okay, it does happen. Okay. And why? I will give you a short answer now, but when we are doing our practicals, right, you will get to know exactly why. Okay. See, this disk platter is there. This disk platter has got the sectors, cylinders, tracks, and all that, right? Now, on top of it, we are writing a file system, right? In Windows case, we saw that the name of that file system is NTFS. Okay. Why that file system is required? To organize the data, right, in those tracks and sectors. So whenever you're storing, let us say, prakash.txt, or let us say Prakash's wedding videos as one folder. Okay. And there are so many mpgs, so many jpegs inside it, right? Now somebody has to keep a track. Okay, this particular file, when it is broken down into chunks or blocks, block 1 is stored on which track, which sector. Block 2 is stored on which track, which sector. Block 3, block 4, so on. And that we saw is called as a journal, or is called as a FAT, file allocation table, right? Now, obviously, for the file system to maintain this data, okay, it needs some storage space, right? It cannot put it in RAM because RAM is volatile. And what is the characteristics of storage? Even if there is no power, this information should be readable the next time I connect the hard disk, right? So this information, the file allocation table, the journal, it has to be stored somewhere physically, right? Where will it store? It will store it on the same hard disk. Okay. So when we do this process called formatting, this is exactly what is happening. When you're doing formatting, the operating system is actually going and reading every track, every sector, every cylinder. Okay. And to each and every track, sector, cylinder, it is giving an ID. And as and when it is identifying these tracks and cylinders, it is updating in this metadata of the file system saying that, oh boss, track number 0, sector number 0 of size 512 bytes is actually physically present here. Okay. And it's there in that file allocation table. Track 1, sector 200 with size 512 bytes is actually there here. Okay. So this kind of a mapping is created, a journal or a file allocation table, and that is stored somewhere. Now this additional information requires some space, so that is the reason why after formatting any hard disk, whether it is in your laptop, whether it is in your phone, whether it is in a desktop, whether it is in a storage system, okay, you will not get 100% of the storage space what is written on the label by the manufacturer. You will not get. Okay. Because of this reason, once you format, additional space is required by the file system to maintain the file allocation table or the generally the metadata of the file system. That takes up space, and that is the reason why you don't get 100% space once you format any particular drive. And you cannot use a drive without formatting, right? Okay, so this is the logic behind it. Now, the reason why I stopped sharing was so understood, Prakash? And everybody else, it's a very valid question. Great. Thank you. So we were talking about object storage. Now, what is the new animal? Object storage. We heard about SAN, okay, high performance, okay, extremely high performance, and used for databases, okay, very low latency, very expensive, dedicated network, used for databases, so on and so forth. Okay, so the industries which use SAN, banks, insurance companies, stock brokers, stock exchanges, okay, travel websites, okay, e-commerce websites, they all use, SAN because of high performance requirements. Then, and that is structured data. Then we have unstructured data, NAS, all your KYC, all these kinds of our own content and media files, all these OTT platforms, all hospitals for medical record storage, okay, all your universities where they're storing your scanned copies of mark sheets and all, okay, all of that is unstructured data. It requires a NAS, okay. But now, what is this object storage? Okay, why there was a need for object storage? The need for object storage arrived because of the scale of the data that needs to be addressed and accessed. Okay. The best example that I can give is YouTube, let's say. Okay. Now, in YouTube, just take a wild guess. How many videos are currently uploaded in YouTube platform? It is billions. Okay. Now, if I have to store that billions of files in the format of a file system, a typical file system, that means every video should have a file name and every video should have a path, right? Right from the root directory to the subfolder to the subfolder to the subfolder to the subfolder and the path, right? And the only way you can access it is by searching that path. Then only the file system will know, okay, I now know that this file is there where, and try to go and access it. So when the file size and the amount of data that you're trying to handle in unstructured data is in just a few hundred terabytes, maybe a few petabytes also, file systems are fine. But when it goes from petabytes to exabytes and zettabytes, file systems will fail, because just to perform search and query on a file system, it takes so much time, okay, that it makes it impractical. to work with a file system on such a huge scale or a mammoth scale. Okay. And that is the reason why all the big brains in this world, they came together and they found a way to access content without a file system. Okay. An object storage does not have a file system. Okay. It is a unique way of directly accessing content without having to go through searching and querying for a path, and without having to maintain humongous amounts of metadata. Okay. So an object storage is somewhere where any user can directly refer and access a content just by using something called as tags or identifiers. Because in YouTube, when you're doing a search, are you searching for any file name? No, you're actually searching for the content that you want. So how is YouTube automatically searching? Yes, there is a searching algorithm, but the content that we are uploading, that is getting tagged based on what is there inside it. Okay. And whenever the users are searching for similar kind of content, automatically based on the content that is there inside, it is automatically able to give it some tags, and based on those tags it is popping up that content. And whenever the user goes and clicks on that content, without having to do any more search and query and retrieve operations, directly that data is published to the user and given to the user. Okay. So it eliminates a lot of overheads in managing and operating huge amounts of data, especially in hundreds of petabytes, exabytes and zettabytes in that scale. Okay. And the applications also, which work with object storage, they do not request for a file, they make an API command to object storage based on the content. Okay. And the tag. So that's how object storage works. Okay. I hope you are getting a broad idea. We will get into specifics later. In fact, we'll actually show you examples of how object storage works, okay, versus a file system. So yesterday, that C colon, D colon, E colon, what we saw on your laptop, those are NTFS file systems. In Mac or Unix-based file systems, root, okay, and then whatever comes under as subfolders, okay, these are EXT file systems, okay, in Linux-based file systems. But where file systems have a cap, like we also saw in wiki that NTFS has a cap, right? 8 petabytes is the cap. A single NTFS file system cannot go beyond 8 petabytes. But do you think YouTube has only 8 petabytes of data? No, it has got hundreds of petabytes. So how can you have a single file system of NTFS managing 100 petabytes? You can't, right? That is where they use object storage. Okay. They don't rely on file systems anymore for large and humongous volumes of data. So we will show you practical examples of how object storage looks like, how to manage and operate an object storage, how you actually upload content into object storage, how you access content. All this we will show you in practical classes a little while later. Okay. So have you understood this concept now? What is object storage and this different kind of storage that has come in because of cloud? Okay. Any questions? Any questions on different kinds of storages on the cloud? Okay. So then we get into use cases, but we will not touch upon that today. We will first learn a little bit more about cloud, and then we will get into all these things. Okay. Because to understand these things, you need to first understand a few more basic concepts. And that is what we are going to start from tomorrow onwards. Okay. So what are the learning exercises for today? We spoke about interfaces, right? So please do a little bit of reading on interfaces. We saw 5 interfaces. We saw SATA, we saw SCSI, SAS, FC, and NVMe. Okay. So please do a little bit of research, come up with a kind of a tabular structure if you can, where you identify what are the physical cables that support these kind of interfaces. Everything is there on the internet, especially in Wikipedia. Okay, you can find them. And what are the maximum speeds of these protocols, interface protocols. Okay, and if you can in your document put some pictures of these cables and interfaces also, awesome, just like the cable and interfaces that I showed you in the beginning of the class today. Similarly, just take pictures, and I showed you on YouTube, sorry, on Google also, how these things are working. So those things can be done. Just give me a second. I have to take this call. Hi, Veena. Hello. Hi, Veena. Good morning. I'm doing pretty well. Veena, I'm middle of an online call. Can I call you back in a few minutes? Okay. Thank you. Bye. Okay. So that is what it is. Any questions on what we have learned today? We have learned about interfaces. We have learned a little bit about what is cloud, what are different cloud types of clouds available. Okay, and we'll go deeper into cloud in our subsequent modules. Okay. And we have also understood a new kind of storage called as an object storage, which has got no dependency on a file system, and it can scale into petabytes and exabytes. Okay, so for learning exercise for today is identify interface, the five kinds of interfaces, identify what kind of cables are used to connect these interfaces, and what are the maximum speeds. If you can put some pictures of these cables and connectors into your document, that will be great. Okay, so create a PDF out of it and just put in same thing. Logical concept is mentioned in that PDF file additional reading which I had shared with you a couple of days back. Now you go and start reading that content. It will start making more sense to you now. Okay, that what exactly are they trying to say in it? All right. Any more questions? Any more questions? Any doubts? No? Okay, great. Uh, Thank you, girls and boys, for your time today. We will meet again tomorrow, and I'll upload the recording of today's class onto YouTube. Okay. Thank you so much. Have a good day. Bye.